This time we are going to draw an inscribed circle. How? Let's have a triangle first because we are drawing inscribed circle in a triangle. So I have this arbitrary triangle here and I will be able to move it, and I need to have a circle that fits inside, something like this. That was poor drawing, but you get the idea. But how do we do this here? Well, for any circle, all you need to know is the center and the radius. So, where's the center? Well, somewhere here. What's the radius? Something like this. The center of an inscribed circle, also called incircle, the center is where the angle bisectors meet. So we just got to cut the angle in half and see where they meet here, shall we? How do we find the angle bisectors here? I think I saw it somewhere. Here, angle bisector. Okay, so I just got to show the angle by picking 3 points. 1, 2, 3. There's the angle bisector of this. Now I'm going to find the angle bisector of this by going around this way. 1, 2, 3. I already know where they meet, but I will show you the angle bisector of this guy has to meet at the same. Here. So 1, 2, 3. They meet like that. So let me move the triangle here to show you. They do. They don't go off sync. Okay, but how do we draw a circle? The circle will go from here to the edge here. So how do you know where the edge is? Well, let's see if we can do it. So here's the circle center. That much we know. Let's have a point first. So let's go. Let's see if I can light up all 3. There we go. I got this. So now I got to go to the edge somehow on the circle, on the edge here. So how can I get to that? See, I could end up in the wrong place. Let me show you here. Circle goes from here. I may think, oh, I think I'm around here. I think it got it. It latched onto the side. But what I'm afraid is that I could latch onto the side in the wrong way, such as this. Oh, that doesn't do, right? It's not inscribed. Look at that. I could go pretty far. So that doesn't do it. Okay, let's get rid of that guy. So how do I go? See, I have to reach the line in a perpendicular way because that's how you measure distance here. So I need to have a perpendicular to this one or that one. So let's do a perpendicular line. It's not bisector, perpendicular line to this one. That goes through the center. There we go. That tells me where the radius should touch. Here we go. So I go from, should I set the point here? I may not need to, but I want to make sure that I'm at the perpendicular, at the cross section, at the intersection here. Let me see, I got that point right. So as I move this here, that point got to stay on there and got to be perpendicular. It is working. So now I can have the circle to go from here to there. That one, I would not be able to move, see, because it's supposed to be perpendicular. If I moved it, it's not perpendicular. Now, I am able to move the circle anywhere I want. See how nicely it fits inside? Right? Always fits. But all these angle bisectors are making you dizzy. So what do we do? Right click. Here. Right click. And right click. What about this perpendicular line that saved us? Well, you got to go too. Gone. Now, you can actually hide a point too. Okay, so now, as I move it, you see, magically it stays inside. Inscribed circle.